Everyone's talking about AI agents replacing workflows, but here's the part most people skip. How do these agents actually connect to your company's data, tools, and systems without creating chaos? In this video, we're breaking down the key building blocks behind modern AI integrations, APIs, MCPs, and gateways. You'll learn what each one does, how they're different, and why they matter when large language models need to access business data, call tools, or safely take action inside real software environments. By the end, you'll understand the architecture behind AI-powered systems, and why the future of enterprise AI depends not just on smarter models, but on better ways for those models to connect to the world.
Welcome to this explainer. Today, we're diving into a massive architectural shift in how modern software and AI systems actually talk to your business data. The ground is fundamentally shifting right beneath our feet. We're moving away from rigid, predictable software and stepping into the world of dynamic, thinking AI models, and, well, that requires a totally new approach to data connection.
Here's our roadmap for today. We're going to cover connecting AI to data, APIs as the classic method, MCPs built for AI, the API wrapper problem, when to use which, and finally, gateways and security limits. Let's jump right in. Starting off with Section 1, Connecting AI to Data, in the brand new integration challenge we're all dealing with.
So let's start with a really foundational question. When you type a prompt into an LLM, how does it actually physically get the information it needs to give you an answer? I mean, it doesn't just magically know what's sitting in your secure internal databases, right? It has to go fetch it. But how?
To understand the new way, we have to look at Section 2, APIs, the classic method, and really the absolute backbone of modern software.
For years, the go-to answer has been the trusty API. Basically, an API sends a request in a strictly agreed-upon format to another system, and it gets a response back in that exact same format. The key thing to remember here: every single detail of this interaction is hard-coded. Developers write the exact code to make the call and the exact code to handle the response. It's incredibly precise and it's super reliable.
They are absolutely perfect for app-to-app communication. It's kind of like ordering off a very specific restaurant menu. The app says, "I'll have item X," and the API says, "Here is item X." Easy, right? But here's the catch. AI doesn't always order off the menu.
Which brings us to Section 3, MCPs. These are built from the ground up for AI, truly empowering the LLM itself.
Now contrast those super strict API rules with the Model Context Protocol, or MCP. Look, AI models don't always know what they need ahead of time. They have to read a human prompt and just figure it out on the fly. So an MCP gives these models a structured way to access a bunch of different data sources through one single interface. Instead of a rigid request, the AI itself actually gets to suggest which tools or resources it needs based on what it thinks is relevant to your prompt.
To make this magic happen, an MCP server equips the AI with 3 specific abilities. First up, tools. These are actions the model can actively take, like searching a database or creating a file. Second, resources. This is the background information the model can read to get context. And third, prompts. These are reusable templates for common tasks, so you don't have to write a massive essay every time you want it to do something routine. It's an entire architecture built specifically around the AI being in the driver's seat.
Let's move on to Section 4, the API wrapper problem, and the very real danger of token waste.
Now you might be thinking, well, why not just slap an MCP wrapper around our old APIs and call it a day? Okay, here is the huge problem with that shortcut. A traditional API might be hard-coded to return an entire customer record. We're talking maybe 50 different database fields. But what if the LLM just needs to know if the account is active? It literally only needs one single entry, not the whole shebang.
When you feed the AI all 50 of those fields, it doesn't just magically ignore the 49 extra ones. Nope, it has to process every single extraneous byte just to find that needle in the haystack. And doing that burns through expensive processing tokens. It's honestly like setting money on fire. Worse than that, drowning the model in extra context can actually confuse it, tricking the AI into hallucinating and giving you completely inaccurate answers.
So how do we actually choose? That's Section 5, when to use which, and finding the right balance in your systems.
In the real world, you don't actually have to pick just one. They are going to live side by side. You'll use APIs for those predictable app-to-app tasks. Think about your banking app checking your balance, or a payment platform. Both sides know exactly what data is exchanging hands. But you flip the switch to MCPs for AI to data tasks. This gives the AI assistant the flexibility to pull exactly what it needs for unpredictable, variable queries, without getting buried under a massive API data dump.
Which leads us right into our final topic, Section 6, Gateways and Security Limits, and how we establish perimeter controls.
Okay, with all these traditional apps and new AI agents aggressively fetching data all over the place, we absolutely have to talk about security. Enter the gateway. A gateway sits right in front of both APIs and MCPs, giving you one centralized spot to handle the big stuff: authentication, enforcing rate limits, logging requests, and access control. You absolutely have to know who or what AI is asking for data and what they're actually allowed to do with it.
You can think of these gateways essentially like a traditional network firewall. They operate at the network layer, acting like a traffic cop, arbitrating and recording data as it flows back and forth. They are a fantastic perimeter defense to keep unauthorized traffic out of your systems.
But, and this is a really big but, check out this quote from our source material. MCP and API gateways are arguably perimeter defenses that will not reliably prevent data-related incidents. Wait, why? Well, because they only operate at the network layer. They simply cannot fix problems happening at the software layer. If you've got faulty, rigid code doing exactly what it's told, even if it's wrong, or if an AI just starts acting unpredictably with data it is fully allowed to access, the gateway is completely blind to it. It just checks IDs at the door. It has no idea what the guests are actually doing once they're inside the building.
So that leaves us with a pretty massive question. Are your AI security gateways just providing a false sense of security? If you're relying on a network tool to solve a software layer AI problem, you might want to rethink that strategy. All right, that is a wrap on this explainer. I really hope this deep dive into APIs, MCPs, and gateways helps you navigate this wild new era of AI integration. Keep learning, and I'll see you next time.